Kia ora. I just had a question on the student forums here regarding something called transient terms and finding the interval of existence and uniqueness for a couple of problems. So I thought it would be easy to answer this question on a video. Okay, so let's start with what is a transient term. Okay, well, a transient term is effectively a term that if we take the limit of that term as the independent variable goes to infinity, if that limit goes to zero, if that term goes to zero in that limit, then that is called a transient term. Okay, if that term does not go to zero, then it's not a transient term. Okay, it stays around no matter what the value of x. Right. So for example, if we're solving some kind of differential equation, it could be a separable differential equation, it could be a linear ODE. Well, let's just make up an example. So, and I solve this ODE and I find some solution that has some function of x plus some other function of x plus some other function of x, so as many as you like. To find the transient terms, I just look at the limit as x goes to infinity of f1 of x. Similarly for the other two. So limit as x goes to infinity of f3 of x. Okay, so let's just totally made up example here. Let's just say the limit as x goes to infinity of f1 was equal to 12. Let's say the limit of f2 as x goes to infinity was 0, and the limit as f3 goes to infinity was infinity. Okay, so in this case, the only transient term would be this one in the middle, because it is disappearing or it's going to 0 as x goes to infinity. So transient terms are those terms that approach 0 as x, or let's say x goes to infinity. It doesn't have to be x, of course, it's just the dependent variable, so as the dependent variable goes to infinity. So let's look at maybe an example with actual numbers in here. So let's go say we solved some differential equation and we found the solution was e to the negative 2x plus e to the x plus, what should we say, 1 over x. Okay, well, let's chuck in a sine of x as well. Why not? So let's say we solved some differential equation somehow, and we found that this was the solution to the differential equation. If we were asked to find the transient terms in this equation, well, there's 4 terms here that to be tested. Okay, we're going to test each of these terms here. So the limit e to the negative 2x as x goes to infinity. Okay, well, as x goes to infinity, we get the exponential of negative 2 times something that's going to infinity. So we get basically e to the negative infinity, which is 0. So this is a transient term. Oops. Okay, then let's check the next one. So the limit x goes to infinity of e to the x. Okay, well, as x goes to infinity, e to the x goes to infinity, so it's not a transient term. Let's check the next one. Limit as x goes to infinity of 1 over x. Okay, well, as x gets larger and larger, as x goes to infinity, 1 over x approaches 0, so this is a transient term. Okay, and then finally the limit as x goes to infinity of sine of x. Okay, well, this is just not equal to 0. Okay, well, maybe you'll study this more in your algebra classes or your analysis classes, but the limit as x goes to infinity of sine of x is not going to 0, so it's not a transient term. Okay, so hopefully that clears up for you what a transient term is. I guess one thing to watch out for is if you have something that look like this. Let's say e to the x plus 12x plus 7 divided by, I don't know, e to the 2x. So here you've got to be careful how you define your terms. So there's three terms to check here. There's this term, e to the x over e to the 2x. There is, how do I change color? Let's go green. There is this term, 12x over e to the 2x. And then there is this term. Okay. So just be careful when you're looking at fractions that you correctly identify the terms. Okay, good. All right, so the second part of this question was looking at specifically the interval of existence and uniqueness for questions D and E. So that refers to the study guide 1.4 questions D and E here. So I wonder if I can copy and paste this somehow. Let's see if this works. All right, let's see if I can paste. I might be having some problems here pasting. Okay, I'm going to pause this for 1 second. Okay, I'm having some problems copying and pasting at the moment, so I'm just going to write it out. So we have question D, which was y dx minus 4 times x plus y to the power of 6 dy equals 0. So maybe let's start with this one. I'm just going to change the color. I don't like that blue. Let's go black. So I want to rearrange this equation here to try to get an equation that I know how to solve, a differential equation that I know how to solve. So I could try and find dy by dx by dividing through by dx over here. But if I do that, I can already tell I'm going to have a nonlinear ODE because I've got this y to the power of 6 term here. So I don't really want a nonlinear ODE. So I might actually try and do this, what we might consider backwards. I might look for dx dy. Okay, and the reason I want to do that is because, well, if I do that, then the term x here appears linearly, so I'm going to get a linear equation. Okay, so in this case, y is going to be my dependent variable, independent variable, and x is going to be my dependent variable in this case. Okay, so I can rearrange this equation to write this as a first order linear equation. Okay, so well, let's do that now. So if I divide through by dy, then I'm going to get dy by dx, dx by dy. I want to also divide through by y, this y here. Oops, I lost it. I also want to divide through by this y here to get just dx by dy on its own. So if I do that, I get dx by dy minus 4 over y equals, what do I get? 4 times y to the power of 5. If I can write that on the right hand side like that. And I've missed an x here. There we go. So if I rearrange that equation, I can write it like so, because now this is a first order linear equation. Okay, I can solve this using the integrating factor method, right? Solve using integrating factor. Okay, and so I'll leave you to do that because that wasn't actually part of the question. What I was asked in this stream post was, well, how do I find the interval of existence and uniqueness for this problem? What's the largest interval that we're guaranteed to have a unique solution? Okay, so there's two things I want to say here. So far in the class, we've learned two existence and uniqueness theorems. One has been for any general first order ODE. Okay, where f of x, y here is some potentially nonlinear function of x and y. And so if you recall the existence and uniqueness theorem there, we had to check the continuity of the function f of x, y, and also the derivative, the partial derivative of the function with respect to the independent variable. So we had to check the continuity of this thing, of these two things. Okay, but the second one, second existence and uniqueness theorem we've learned was actually for first order linear ODEs, okay? And so if we had a first order linear ODE in this form here, what did I call the right hand side? Let me just check. So this is from lecture 5 in the course notes, so you might want to reference that. I just called it f of x. Okay, so this is a general first order ODE in its standard form, the general form. So for existence and uniqueness of a first order linear ODE, what we have to do is check where p of x and f of x are continuous. Okay, so maybe it's probably a little bit easier, this first order linear type, because we don't have to calculate any partial derivatives. Okay, so this number 2 here, this is what we're going to use to solve these two problems in the study guide. Okay, so let's rewrite that study guide problem again. So dx by dy minus 4x over y equals 4y to the power of 5. Okay, so, well, our independent variable here is actually y, so we're going to say p of y now rather than p of x. So p of y is equal to negative 4 over y. And f of y, because remember, y is our independent variable here, is just the right-hand side, so we get 4y to the power of 5. Okay, so we need to check the continuity of these two functions. Well, f of y is fine. F of y is continuous for all values of y. P of y is continuous for y not equal to 0. Okay, so there's a problem with this function p if y equals 0, right? Because then we divide through by 0 and, well, that doesn't work very well. Okay, so p of y is continuous for all y equals 0. So the only problem point out of these two functions, the only problem point is y equals 0. Okay, so, well, the question, I believe, asked for the largest interval over which we're guaranteed to have a unique solution, or is guaranteed to exist a unique solution, is going to be 0 to infinity or negative infinity to 0. Okay. So this is the solution to D. I think I will leave, D was here. I think I'll leave E for you to try. But always remember, you do have the solutions on the stream page to the study guide problems, so you can check there. So hopefully that's clarified a few things for you in terms of transient terms, and also in terms of how do we find the interval of existence for first order linear ODEs. The main point is, if you have an ODE in this form, check the function p, check the function f, and see where there are problem points there. See where they're continuous or where they're not continuous. Okay, hopefully that helps. If not, please let me know and I'll try to help some more. Thank you.